right, we're continuing with Chapter 5, Section 1. Today we're going to go over all of the rules for reference angles. So what I'd like you guys to do with me, instead of just copying things down, we're going to copy things together. First thing I'd like you to do is I'd like you to make an x-axis and a y-axis, make a Cartesian plane here. All right. All right, so x, y. What I'd like to do is I'd like to label this Lester. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and eventually you could also say, this would be at 0 or 360. Okay. This is the reference angle rule for quadrant number 1. Just a minute. Right, quadrant 1. All right. What I want you guys to do then, if you have twistables or a highlighter or some type of colored pen, I'm going to draw a green ray, and I'm going to label this green ray my initial side. I'll pause it so you guys can get your color. All right. After you've drawn in your initial side, the next thing we're going to do is I'm going to make a terminal side. However, the terminal side needs to finish somewhere in the first quadrant. So I'm just going to randomly choose a space right there and make it finish in the first quadrant. I'm going to label this side my terminal side. Okay? And by the way, on this picture you'll see the lowercase Greek symbol for alpha. I'm going to change this symbol from alpha to theta. And I'm going to put, this is the Greek symbol for theta. I'm going to write the word so you know how to spell it. That's theta. Now theta is just going to be a representation of the angle that I just made. And I'm going to highlight the angle that I just made. And this nice magenta color. No, it's theta symbol. Okay? So right here, let's say I said that theta was approximately equal to, say, 60 degrees. Okay? If I said theta was equal to 60 degrees, here's the reference angle if your terminal side is in quadrant number 1. Your reference angle will always equal whatever theta is. So what's my reference angle? 60 degrees.
Always equal.
In quadrant 1, your reference angle is always equal to whatever theta is. Whatever that angle is, that's what your reference angle is for quadrant 1. That's probably the easiest one. While you guys are finishing things up, what I'm going to do is I'm going to make another Cartesian plane. And we're going to do the rule, not for quadrant 1, we're going to do the rule for quadrant 2. This is where the terminal side will eventually finish in quadrant 2. I'm not going to label 0, 90, 180, and 270 because we've already done it once, so you should still know that we're still dealing with 0, 90, 180, and 270. But I am going to create a new initial side. I'm going to make my same initial side is going to be in green. My terminal side is going to be in red, but I'm not going to finish in quadrant 1. I'm going to go all the way over to somewhere in quadrant 2, and I'm just going to randomly place it right there. Now, let me explain to you my theta from the initial side, my actual amount of degrees that I rotated in a counterclockwise direction. I'm going to say theta is approximately equal to, say, 150 degrees. The rule that you would use if your terminal side, by the way, this is your terminal side, the red side is your terminal, the green side is your initial. Yes. your reference angle will equal 180 degrees minus whatever the measure of theta is. That's the formula. That's the rule right here. It's 180 minus theta. So our reference angle would be 180 degrees minus 150 degrees. So our reference angle in this particular case would be 30 degrees, which is referring to this angle right in here. So this measure from here to here, that's your reference angle. That's 30 degrees. Your reference angle, everybody, will always be a positive number. Okay? It's never going to be negative. Now, your initial side and the way you turn it, the way you start your terminal side, it might end up being a negative, right? But I want you guys to understand your reference angle will always be a positive. Now, something that I forgot to mention, one second, that I need you guys to put right up here in the top right-hand corner of your journal. I want you guys to understand that whatever number that you use for theta better be between 360 and 0. So whenever you're dealing with theta, make sure it's a positive number that's between 360 degrees and 0 degrees.
Why couldn't it be between 380?
Because 360 degrees is all the way around a...
Oh, I mean, yeah, 360.
Okay? So, whenever you use this formula, whatever theta is in all the particular places, in the little equations or the rules, theta will have to be between 0 and 360.
Will you be given that word? Yeah, will you be given like that?
Yeah, you'll be given a certain amount of degrees that you have to rotate, either clockwise or counterclockwise. All right. Right now we're showing you the rules for reference rules. All right. Now, what do you think I'm going to do next?
Quadrant 3, maybe.
That's right. Quadrant 3. Here we go.
How many is
What
there?
you get?
Good. Hey, by the way, the good thing is we're right there. If somebody tells you that you're going to have to do 5 quadrants, they're lying.
They're lying?
Just like whenever you're playing poker and they say they won because they have a toilet flush, there's no such thing. A royal flush is the best hand of poker. A toilet flush doesn't exist. All right. Trust me, at some point, people who are trying to teach you poker or playing, they're like, oh, we'll teach you how to play. And they're like, I beat you, I have a toilet flush. You're like, what? There's no such thing. All right. Yes.
So you
Just like if I told you that there was a quadrant 5, there is not quadrant 5.
That's like road 2.
Yeah, it's like there's not going to be a Road 2 movie.
Wait, why?
They're all dead.
No, listen. Listen. The gap, let me explain this. The gap between the movie Road 1 and the movie also known as A New Hope is about 15 seconds.
It's literally the opening of the door.
Because all the
Have you seen Star Wars?
From the
Yeah,
end to the beginning.
Anyways.
And it's like it shows you the door in the end of one, and then it shows you the door
Forrest
in the
Whitaker
beginning
was
of
in
the
that
second.
movie from Longview, Texas.
Huh?
Forrest Whitaker's from Longview, Texas.
Can we get back to that for a second?
Why do you
Road
actually want to dot on
I know, because I'm trying to, we're trying to do a little math here, Alyssa, okay?
We're not recording.
Yeah, we are recording. Right now, it's still recording.
Hey guys, how's it going?
I don't know what you're talking about.
Did you rate
This video is sponsored by Lucasfilm.
Yes, I accidentally put 4 here because I was thinking about Star Wars and A New Hope, okay?
Yeah.
Disney
Yeah.
Lucasfilms out of
Alright, I'm going to pause this video and crack some skulls. Alright, on to quadrant 3. What I'd like you guys to do, we're going to have the initial side right here. But now your terminal side is not going to finish in quadrant 1, nor quadrant 2. We're going on to quadrant 3, so I'm just going to randomly put it, say, right in there. At this point, I want you to understand, we started here, and we went counterclockwise all the way around to our terminal side. How far did we at least know you had to go? At least we went past
More than half of.
more than 180. Right, more than half of a circle. Right. So we have 180. I want you guys to understand. We went. I'm going to say theta. By the way, this right here is your theta.
210.
I'm going to say is
210.
210.
I'll say 235.
235.
Good.
235. We're just gonna say randomly it's 235.
But it's closer to the.
Actually, you know what? Not 235. We'll make it 225. There you go.
Is that final?
That's fine. 225.
Sure, we can't
That's
get
exactly what I have
boys,
right
get
now,
boys
too.
210.
All right. Here's your rule for reference angles in quadrant 3. Your reference angle will equal theta minus 180 degrees. This is your rule, everybody, for quadrant number 3.
So correct me if I'm wrong, the quadrant number 2 was 180 minus theta. This is theta minus 180.
By the way, this number right here, theta, is definitely between what? It's between 360 and 0. So if we do 225,
We couldn't have a 361. It'd have to
No.
be 3, had to be 3.
it has to be 1.
Oh yeah, because it would just start over in the
Right.
circle.
So 225 minus 180.
That's like 45.
So our reference angle, everybody, for this particular example is 45 degrees. Let me show you where this 45 degrees is located. Right here. This 45 degrees is located right there. We'll label it 45 degrees. By the way, your reference angle is always in relationship to the x-axis. Your reference angle is always in relationship to the x-axis. You see how this angle is made with the x-axis right here? This angle is made with the x-axis right here. This one is made with the x-axis right here. And we have the final quadrant dealing with quadrant 4.
Yeah, that was kind of throwing me off. I was kind of thinking, why would they-
All right, so now the final one. Quadrant. No, not quadrant. We're not gonna go off- We're not going to go off on that thing.
You okay?
Yes, Taylor, I accidentally wrote quadrant 4 for quadrant 3 in the last one.
You did.
All right, I erased it quickly, but it's definitely in the recording. I was hoping that we noticed, but
I know.
you noticed. All right, so here's our quadrant 4. That's just all right.
Don't be sad. It's a countdown. Perfect.
All right, so our initial side, by the way, our initial side is still with the green ray. We're going to now finish somewhere, not in quadrant 1, 2, or 3,
And 4.
and 4. I'm going to make it finish right there.
So that's a mini quadrant.
That's it. What I'm doing now, everybody, is I'm drawing the representation of theta. Theta is obviously this time going to be past 270 degrees. So right now I'm going to say, in this particular example, I'm going to say theta is about equal to 300 degrees.
So we're just guessing.
No, I'm kind of using some mathematics. All right, Alyssa, if I wanted to kind of get more accurate, I could take my protractor.
And what's that?
Well, we'll find out. Oh, man, pretty close.
Dang, Mr.
See right here, that's about 30 degrees. It's almost 30 degrees.
Move it a little to the left. We'll be there.
Yeah, well, I already drew it. So we're saying theta is about equal to 300. Here's the last rule, everybody.
All you do is move the protractor.
Is there a risk of them letting do?